So today we're going to be learning about derivatives of trig functions and a little bit of application of that. So up here we have our 6 trig functions: sine, cosine, tangent, cosecant, secant, cotangent, and these are their respective derivatives. Okay, so this is stuff that you do need to memorize. A little hint for me is if you take the derivative of a c word, it's negative. So look at all of our c's. They produce negatives. Okay? And then if you do tangent, you're going to get a secant squared. And if you do cotangent, it's the other one squared, which is cosecant squared. And since that starts with a c, that's negative. So just a couple things just to help you remember that. So let's go through this. Let's differentiate this function right here, which means find y prime. So when we do that, this is going to be good old product rule because we have a function here of x squared and we have a function here of sine of x. Okay, so when we do this, we're going to get 2x and then leave the second alone, plus x squared, leave the first alone, derivative of the second, which is going to be positive cosine of x. And that's good enough right there. If you want to take a GCF out for giggles, be my guest. And that's good enough right there. So just familiarizing yourself with a little bit of trig. Okay, so we have this next example. We have a function of the secant of x all over 1 plus tangent x. And it wants us to, it doesn't say it, but we want to find f prime. Missing some notes here, but let's go ahead and find f prime. So to do that, it's going to be the first is first, so we're going to take the derivative of the top. So what's the derivative of secant? If you don't know, because you're new to this, just look at the front right here. So the derivative of secant is secant x tangent x, and then the bottom stays, minus, leave the top, secant of x. And then derivative of the bottom is going to be 0 plus derivative of tangent is secant squared. All over the bottom, which is going to be 1 plus tangent x. And that's all going to be squared. Okay, so we're going to clean this up just a little bit here. Way to clean this up here is to find a, could always find a GCF. So, or we could just distribute. It's probably the best thing to do is distribute here first, and then you can find a GCF. So let's go ahead and do that. So I'm going to get secant x tan x plus secant x tangent. There's 2 tangents to that second one, so tangent squared x minus secant cubed x all over this 1 plus tangent x squared. Okay. So that's good right there. If you're doing multiple choice, they might have some weird stuff as answers. So you need to play around with this a little bit in case this doesn't match up. So like one that I know is going to happen here is I know that tan squared minus secant squared is an identity. So if I take out a GCF of the second one, now are you going to know how to do this? No, but if you look at your multiple choice choices, you might be able to figure out something. So secant of x is going to give me tangent squared x minus secant squared x. And that's going to produce a, if you know your identities, this right here is going to produce, grab another color, it's going to produce a -1. This equals -1 for your identities. Okay? So that's going to give us secant x tan x minus secant x. 1 plus tangent x all squared. And again, the last thing we could even do here to simplify would be the final answer. Take out the GCF of that secant, and you're left with tangent x minus 1 all over 1 plus tangent x all squared. So it's just rewriting it from here to here. This is why we have to be sharpen those pre-calculus skills with those identities that we did previously, just so that we're capable of rewriting it. Now, did I know right off the bat that we have to do this? No, but I'm just showing you different things you could do, and this is actually the only thing that you could do for that one. Okay. Let's go ahead and do this application problem right here. It's going to throw some people for a little loop here, so pay close attention. So we have on a sunny day, a 50-foot flagpole casts a shadow that changes with the angle of elevation of the sun. Let S be the length of the shadow and theta be the angle of elevation of the sun. Find the rate at which the length of the shadow is changing with respect to theta when theta equals 45 degrees. Let's express this in feet per degrees. So if I have a nice little problem here where I have a sun, there's my sun, it's in yellow. There it is. There's my sun. All right. And then it is going to be this pole that is 50 feet high. And it's going to cast the shadow like this. So this is 50. And right here is theta. That's the angle of elevation, is always on the ground, no matter what. The angle of elevation. And then this is the shadow. Do this in gray. So there's my shadow of the pole. S is for shadow. Okay? So to set this up is, well, actually, let's see what we're looking for. We want the rate of change of theta. So we want ds d theta. We want the change of theta with respect to the shadow. Okay? And this is when theta is equal to 45 degrees. Okay? So we need to take the derivative. So we need to create a function here with our information that's going to give us a derivative. Well, I do know that this is going to give me a tangent of theta is equal to opposite over adjacent is 50 over this s. Okay, that's an s, not a 5. So now I just need to take the derivative of s when it's by itself. So then that would produce this ds d theta. So to do that, I'll multiply the s on the other side. So it's s times tangent theta, which equals 50, and divide that tangent over. So I'm going to get s equals 50 over tangent. 50 over tangent is the same thing as 50 cotangent. Okay? So now that's my setup. I'm ready to go ahead and take the derivative. So I'm going to do that with respect to theta. I'm going to get ds d theta. And take the derivative of this, which is the derivative of cotangent of theta. If you don't know, got our little handy little sheet over here. It's negative cosecant squared x. So it's going to turn to negative 50 cosecant squared x now. It's going to be stay theta. Okay. Now, what's a little nifty about this is that since we're at 45 degrees, the sun right here is going to be at 45 degrees. We need to plug in figure out what cosecant of 45 degrees is. So this equals negative 50 cosecant squared of 45 degrees. Well, what is cosecant of 45? Do you remember? It is root 2, isn't it? So it's going to be root 2. So I'm going to get negative 50 times root 2. And then you got to square that. So you're going to get negative 100. And anytime you take the derivative of a theta, it turns into radians. So this is going to be feet, because the problem had everything in feet. The rate of change is going to be feet per radian. All right, now did that answer our question? I didn't. It says express your answer in units of feet per degree. So I have to convert this. So to convert this, I'm going to have negative 100 feet per radian times pi over 180 is going to convert that because pi radians on top and then 180 degrees on the bottom. So that will convert it from radians to degrees. So it's convert anything raised degrees multiplied by pi over 80. Again, this got all of this from pre-calculus last year. So you're going to end up getting here a negative 100 pi over 180 feet per degree. But we can simplify that a little bit, right? It looks like we can take out a 20 out of each of these. So we're going to get negative 5 pi all over 9 feet per degree. So what this means here is that the shadow length is decreasing as time goes on. Okay? And that's a little bit of application stuff. We're here with the trig functions and then the derivative of it. And again, the big thing here is you have to memorize these 6 things soon. Like now. Memorize it now. That's all.